her presentation is about the use of new approach.
Thank you for your induction and my introduction. And my name is Yunjia. Today I'm going to share my master's studies with the topic showing on the slide. And my advisors are Professor Lin and Professor Chu. First, the background is the bisphenols we chose to study for, and the BPA was the most famous one because the widespread use and its endocrine disrupting effect. And the analogs have appeared in the environment because the regulations on BPA. And some of them has the similar endocrine disrupting capability similar to BPA, but the toxicity data are still lacking. And here is the new approach methodology. It including the in vitro assays and in silico models and in vitro to in vivo extrapolation, etc. And it's alternative to the animal testing. Because of the bans on the BPA and lots of substitute is showing in the market, then their available exposure data of them is little to no in Taiwan. And most of them has the endocrine disrupting effect similar to BPA. So it's necessary to conduct a thorough research and can assess their safety to humans. And besides, combining the new approach methodologies adopted by the organization and many countries, lots of to conduct it with them to assess the risk assessment. And the objective in our study is to develop a NAMS-based risk assessment that integrates the total data study and the in vitro assays and the in silico modeling to assess the mixture risk to the exposure to multiple bisphenols and for different ages in Taiwan. So the flow chart is about 3 parts. And first, we will define the sampling list with the Corford approach. Then we will use the UPLC mass with Quinter's method then to analyze the concentration of our BPs. And we will estimate the dietary intakes for different age groups. The next part is to collect endocrine-related in vitro assays in tox tests, including estrogen, androgen, thyroid receptor, and PPAR and steroidogenesis. And we collected a value like AC50, AC10, and the Emax. Then AC50 will be the flex of cytotoxicity, and AC10 with Emax will conduct the hazard profile and the toxicity prioritized through the ToxPy software. And AC10 also used with the HTTK PBTK model to complete the IV-IVE to derive the human equivalent doses. Then finally, we will take the dietary index with the ToxPy score to get the risk index. Then let's show the risk ranking of bisphenols. And we also use dietary index to comparing to our in vitro derived human equivalent doses to get the combined exposure bioactivity index and show the mixture risk of the endocrine activity to exposure to bisphenols. Then here is the chemical analysis we conducted in the Chang'an University of Science and Technology. The food samples is divided into 4 groups according to their water and fat contents. And the method validations are complied with regulations from Taiwan Food and Drug Administration. And here is the assays we collected and referred to Jackson, Martin, Friedman, and Karmas. Here is the ToxPy software we use, and we collected the AC10 and Emax value from ToxCast from the active assay. And if in active assay, we will convert the data into 10 to power 6 and scale the values in the logarithm, negative logarithm, and plus 6, then to calculate the ToxPy scores. And here is we use the human PBTK models in HTTKR package and combine the AC10 from ToxCast in vitro assays. Then we will complete the in vitro to in vivo extrapolation to derive the human equivalent doses. And here is the detection rate in our analysis. 11 out of 16 bisphenols were detected in our analysis, and the BPA, BPS, and BPF have relatively high detection rate. And here is the mean concentration. Top 5 mean concentration of the bisphenol core food is from the 33 to 7.6 nanogram per gram. Then we found BPA is the only one to found in the canned fish, and the BPS was the only one found in beef and products. Next is about the top 10 core foods in high mean concentration in BPA, BPS, and BPF. For BPA, the 10 core food had high BPA concentration, and the 10 fish had the highest BPA level. Then the BPS has detected a high concentration in seafood and meat. Yes, and the 2,2 BPF show its highest value found in the instant noodles, and the 4,4 BPF found in pickled vegetables. And next is the toxPI cluster analysis of bisphenol. And we can see those three has almost all selected endocrine pathways have activity except the steroidogenesis. And only BPS and BPC has the steroidogenesis activity. And the 2,2 BPF, BPAP, and BPZ has the significant thyroid receptor pathways activity. And those last three have the activity in PPAR pathway. And here is the prioritization. We can see the BPAF has the highest toxPI score, and the BPB and the BPA has the second high and in the same score. And the BPC has a similar score to BPA. Among those BPs, BPPH has the lowest score. Then the preliminary conclusion in our study, we conduct the total gut study, and with the 11 bisphenol to be detected among the 16 BPs, and the BPA found to be the highest detection rate, and followed by BPS, BPF. Although BPA has the highest concentration in most food, BPS play the major contributors to seafood and meat and tangerine and tea and so on. Another part is about we conduct the 5 endocrine pathways, use toxPI to show the potential endocrine pathway activity. And it's worth to mention, BPAF is an analog of BPA, but it has the higher endocrine activity than BPA, and BPB, BPC has the comparable activity to BPA. And this is my presentation. Thank you for your attention.
Thanks, Ms. Yao, to share a rich data from her research. So now we are open the question from the audience. Is there any comment or questions?
Nice, thank you. How the effects differ by so how does the structure effect relationship of the bisphenol A derivatives?
Thank you for your question. And do you mean how was I think about the bisphenol A and another analogs?
Showing the different sorts of endocrine disruption. How about the steroidogenesis or thyroid function?
Can I use this slide to explain? I think your teacher's question means like BPF and BPA, BPD show like in estrogen, androgen, and thyroid receptor and PPAR activity, and another show in other pathways.
So which sort of structure determine such kind of difference of the effect? Okay.
Thank you.
Okay. Thank you, Ms. Yang's presentations. And due to the time pressure, I think we need to close this session now. And thank you everyone to join the session in the morning. And if you have more comment or you would like to share your experience to the student presenter, we can use lunch break. And